Okay, so let's go ahead and talk about Wednesday stuff now. Once again, if you have any questions, here's my email. Make sure to get a hold of me. I can't know you have problems if you don't ask me. So, what we're going to be doing this time is basically the same as last time, but I'm going to give you less information. So, as you're going through, what we're going to start seeing is now I've only given you a side. I haven't given you a side and an apothem, which means that we have to figure something out. What we can do, there's a number of ways to go through and do this, but basically it boils down to the same thing: find the base, find the height. I'm going to talk about this sort of from two different perspectives. First perspective is from the perspective of a 30, 60, 90 triangle, which this kind of is. Really, the one thing that's different is we are now dealing with basically two 30, 60, 90 triangles glued together, right? Each of these three sides um, are the same because it is an equilateral triangle, and so each of these three angles are the same. Um, what that means is each of these is 60, like that. Mm-hmm. And since we know that each of these three is 60, if I were to slice this in half, like so, let's see if I can do it and make it look okay, kind of. Yeah, that's not too bad. Oh, I'm just making things worse now. Let's see if we can make this a little bit easier. Oh, no, it's gonna stay there. That's okay. So, since we've cut this in half, this 60-degree angle is no longer just a single 60-degree angle. We cut it in half, and so what we have here are two 30-degree angles. Now, that also means that this angle down here is 90 degrees. It's a right angle. And as we talked about um, at the beginning of the trigonometry chapter, we realized that we had the ability to take one piece of a 30, 60, 90 triangle and use that to figure out all the other pieces. Now, this is an equilateral triangle, so we don't have to do every single step. We know for a fact that all three of these sides are 33 units, so that actually saves us a little bit of time. But the fact that each side is 33 units, that gives us the opportunity to then proceed to cut everything in half, right? Because we cut the triangle in half to make a 30, 60, 90, so let's cut this side in half. Um, and half of 33 is 16.5. I'm going to put this over here. 16.5. So now that we've done that, if you remember back from the 30, 60, 90 triangle thing we did a couple months ago, um, if we go from the small side to the medium side, the side opposite the 30 to the side opposite the 60, we end up with this right here. We end up with the thing we had before, 16.5, times radical 3. So, whatever this is, put a radical 3 on it, multiply by radical 3, and then we end up with our height. So now, what we have here, well, we've got our base, we've got our height, and we can just find our area, right? So there we go. We're going to plug everything in. And we get 1/2 times 16.5 times 16.5 radical 3. And remember, when we multiply all these things together, that radical 3 doesn't get multiplied to all these numbers, right? So we're just going to do 1/2 times 16.5 times 16.5, and we're going to get our final answer. So let's do that. Well, half of 16.5 is 8.25. So we're going to do it out. 16.5 times 8.25. And we're going to do our multiplication. This is going to be a lot of work trying to do this. So if you prefer using a calculator, you know what, I'm not going to judge you. If you do that in the calculator, 0.5 times 16.5 times 8.25, you end up with a final answer of 68.0625. And then, of course, we've multiplied all the numbers, but we cannot forget about that radical 3. So our final answer here, the area, is 68.0625 radical 3. And if you want your answer to be left in simplest form, this is a perfectly fine way to do it. When it comes to doing all of this the way it is, I'm not super big on taking what we have here and making it into fractions. If you wanted to, I'm sure you could. It would certainly be something over 8. 16, actually. And then you go through and you have all of your work right here. If you're being asked to round it to the nearest however many, either 10th or 100th, then you can just put that in the calculator, although I'm sure doing this we've already put it into the calculator, and that's okay. Proceeding to go through here, when we get our answer, just round to what they tell you to and chop it off as you know how to do. All right, so right here, this type of problem basically defines any situation where we have an equilateral triangle. If you have an equilateral triangle and you've got the side, that's all you need. You don't need to be given the height. You don't need to be given an apothem, because you have the 30, 60, 90 triangle right here. And what basically happens is, you know the side, cut it in half, put a radical 3 on it, there's your height. So let's look at another problem. What did I do? There we go. Let's look at another problem. So here we have a hexagon, a regular hexagon, and the important thing to know about a regular hexagon and why it's in this particular situation for us is because regular hexagons are made of 6 equilateral triangles, like we talked about last time. So if I go through and I carve it up, I get 6 equilateral triangles. Since I have 6 equilateral triangles here, all I need to do is find one of them, and then from there, it's basically just get your answer, just like before. Multiply by the number of triangles, and there we go. So I'm going to pause for a second and see, because this is exactly like the previous problem, the one we just did, just times 6, right? So go ahead and give this a try. See if you can figure it out. And we're back. So let's go ahead and do this. I'm going to, just because it might be helpful, I'm going to draw a triangle here just so we have something to work with. And according to our picture, they tell us that one side is 12 radical 2. And just like before, we need to find what that height is, right? So we go through, we make our height. And in order to get our height, we cut the side in half and multiply by radical 3. And so half of 12 is 6. And then we've got a radical 2 here, and then we multiply by radical 3, and, you know, radical 2 times radical 3. Well, what's 2 times 3? That's radical 6. So our height here is 6 radical 6. So our base is 12 radical 2 when we cut the base in half and multiplied by radical 3, and we got 6 radical 6. And there we go. It's the same exact thing now. We just find the area of the one guy. And that's base times height. 12 radical 2 times 6 radical 6. And half of 12 is 6 times 6. So we've got sort of in gross form 36 radical, well, radical 2 and radical 6. Those two together make radical 12. And then, of course, like we've talked about before, you've got to check to make sure that your radical is in simplest form. Radical 12, well, that's, if we break it down, factors of 12, we've got 2 and 6, and then we can break down 6 because 6 is still composite, 2 is prime. We've got 2 and 3 here. And so when we write everything out, we find here's our perfect square pair. 2 times 2 is 4. We square root that and bring it outside, and now we have a 2. So let's break this radical 12 down. The 36 is still there. And now we've broken down the radical 12. The 2 came out because 4, and then you square root and you get 2. The 3 stays on the inside. It's a single Pringle. It has to stay in. It's quarantined. You know, you gotta be careful. Might have the coronavirus. And then we're just going to finish our problem by making sure that these two are multiplied together. 72 radical 3. And that's one triangle. Well, from here, there's just 6 of them, so we're just going to take 72 times 6, right? Just going to multiply by 6. So 72 radical 3, we're going to take the 72 times 6. And do it really quick. 6 times 2 is 12. 7 times 6 is 42 plus 1 is 43. 432. So we've got 432 radical 3. That's our final answer for this big old hexagon. All right. So what comes next? Well, now instead of being given a side, I'm being given a radius, right? Going from the center to the corner, we call that the radius. And when it comes to a hexagon, remember, a hexagon is made of, that's right, equilateral triangles. So look, that's 10. So what are all the rest of these? 10. see now, it's the exact same problem. So take a minute, try it out, see if you can do it, pause the video or whatever, and then, when you come back, we'll go and do it. Okay, so once again, I'm not even going to bother drawing a triangle this time. I think we're pretty good with this. The base of the triangle is going to be 10. The height is going to be 5 radical 3. If you need to understand why, we can look back here. Remember, the base, whatever the base is, the height, you cut it in half and then multiply by radical 3, and that'll get you the piece that you're looking for with the height. So, let me write that over here just so I don't forget. Base is 10. The height is 5 radical 3. And now from here we just plug it in, right? 1/2 base times height. Plug them in. 1/2 10 times 5 radical 3. And then you're going to do the math. Half of 10 is 5 times 5 is 25 radical 3. And then you count the number of triangles. 1, 2, 3, 4, 5, 6. 25 times 6 had better be 150. 6/4 is $1.50. 25 cents, right? Radical 3. So your final answer here, once you multiply the 25 radical 3 by 6, you get 150 radical 3. So this one actually is pretty simple, especially in light of what we've been talking about already. If you can break it down into an equilateral triangle and figure out the length of a side, you can do this exact same thing and then get the same answer. So on that note, what if we can't do that? How do we figure it out? How do we get where we need to go? So there's a lot of options here, but let's pick the simplest one. Let's find a 30, 60, 90 triangle. Well, just like we said before, we've got 30 degrees here because it's the 60-degree angle cut in half. That's 30. Right? And then all I have to do is make a 90-degree angle, and then what's left over is 60 degrees, right? So let's do that. Well, there's a 90-degree angle, so this must be 60. And then I can just work my way around. Remember, going from the hypotenuse side to the small side, we divide by 2. So we got 4 radical 3. And then going, let me write that out, divide by 2. Right, and then 8 divided by 2 is 4. And then going from the small side to the medium side, we multiply by radical 3. And, I'll do this up here so you can see it, but 4 radical 3, well, times radical 3. What's radical 3 times radical 3? It's just 3, right? When you multiply the same thing to the same thing, it's like you're squaring it. So you square it, the radical goes away, and you're just left with 4 times 3, which is, in fact, 12. So this piece is 12. Now, if you're going through, you've got a ton of different opportunities at this point, and it really basically just boils down to, what do you personally prefer? If you're good with the 1/2 AP situation, like what we had in the last one, well, look, you're going to have the whole length of the side. You're going to have the apothem. So all you need to do now is just say, well, one triangle, 1/2 base times height, and well, I need the whole base. Well, this is half of it, isn't it? So the whole base here for the whole side here is 24. Well, what is that? That's 1/2 times 24 for the base, and then the height is the apothem, and that's 4 radical 3. Well, half of 24 is 12, and 12 times 4 is 48, so one triangle, you've got 48 radical 3. Well, this is one triangle, and then if you look at the way that it's set up, drawing from the corners like we're used to, going here, we're going to have 3 of them, right? So 1, 2, 3 triangles. We can just multiply that by 3. And 48 times 3, well, 8 times 3 is 24. 40 times 3 is 120, and so we end up with 144 radical 3 for the whole thing. Now that might not be your jam. You might be saying to yourself, that's a lot of work. And you're not wrong. It's one way of doing it. If you would prefer, now you've got the 24, and then you know that the height of the whole thing is going to be 12 radical 3. You can do that same thing, and you're going to get the exact same answer. And this is, again, it's a different triangle. We're going to do the whole triangle this time all at once because it's a equilateral triangle, and equilateral triangles are easy to work with because the base is going to be one thing, and then to get the height, you divide by 2, put a radical 3 on there. So let me write out my formula. My base is just the one side of the triangle, 24 units. The height is, cut that in half and put a radical 3 on it. So half of 24 is 12. And don't forget the radical 3. This is special for an equilateral triangle. So don't just do it randomly, I guess. But anytime you've got an equilateral triangle and you want to do this, it is fair game to do. And you're going to see when you do half of 12 and times 24, you're still going to get 144. Radical 3. Either way, you got the same answer, and it really just depends on what do you prefer. Some of you are going to, because you're good with the 30, 60, 90 triangles, you're going to go through and you're going to just stick there. Okay, I want to work with this little triangle. That's fine. Some of you are going to want to jump out of that immediately and just go back to what we were just talking about with this guy, finding the side and then the height of the whole triangle. Either way is fine. You will get the same answer either way, and both ways work really well. And I'm sure there are thousands of other ways. I think I probably put 1 or 2 other ways on the guided notes that I posted on the Google Classroom. So it just really depends on you. What do you like? All right, this one right here, this is going to be a little bit different because now we're working with a 45, 45, 90 triangle. And as you're going through, there's about 1,000 billion million different ways to carve this up. But if you notice, look, here's a 45-degree angle. And then if I draw my, oh, it skipped off the page. That's sad. Well, I'll do it down here. It's the same thing. Because if this is 45, then this is also 45, right? They're the same. They're half of a 90-degree angle because it is a, and I am, of course, moving this around because I forgot to click lock. Well, let's do that right now real quick. There we go. Now I can move around the 45 like I wanted to. Hey, put it over here. Because they're the same, right? 90-degree angles cut in half make 45-degree angles. And if that's 45, well, what I've done is I've made a 90-degree angle right here. And a 45-degree angle right here. which means that I've made a right isosceles triangle, also known as our 45, 45, 90 triangle. Well, if this is 11, 45, 45, 90 triangle time, this is also 11, right isosceles, right? These two sides are the same as each other. And then depending on how you feel about it, you can either use the Pythagorean theorem, a squared plus b squared equals this thing we're trying to find, the side of the square, right? Equals c squared. So or you could use the 45, 45, 90 triangle thing that we know, that if I go through and I go from the small one to the big one, I multiply by radical 2. And then from here, I know that this is 11 radical 2. Well, isn't that just the side of the square? And if we want to find the area of a square, it's just take the side and you square it. Side squared. And our side is just 11 radical 2. And we're going to square it. Just like that. Well, then now we just square the pieces in there, right? 11 radical 2 squared is just 11 squared, and radical 2 squared. Well, 11 squared is 121. 2 squared is 2. No, radical 2 squared is 2. 2 squared is 4. But we don't care about that. We want radical 2 squared. And that's 2. And then we do 121 times 2, which is 242. And look, there's our units. That is our area of our whole square. So we went through and we said, all right, well, I know this is 11. So I know this is 11 with my 45, 45, 90. Times radical 2 to get the hypotenuse of the 45, 45, 90 triangle. And that happens to also be the side of our square, which we can now use to find the area of the whole square. All right, I think we've got a couple more. This one, here they've given us the apophthegm, and we need to figure out the side. And again, it really basically boils down to how do you want to go about doing this. I'm going to go through and I'm going to show you the way. Let's make it, didn't put it in a nice place, did I? Let's try that again, maybe. Let's do it over here. Alright, so we want to, our goal is to figure out what this side is so we can do our equilateral triangle shenanigans. And I know this isn't so equilateral, but that's okay. Just pretend. And we know that this piece is 16. And if we're doing this, remember before, if we knew what the base was, we could divide it by 2, put a radical 3 on there, divide it by 2, and multiply by radical 3 to get what we need. And, you know, in some ways you could say, well, let's multiply by 2 and divide by radical 3, right? And that'll get you this piece. This whole thing. So let's do that. Well, 16 times 2 is 32. And then we divide by radical 3. And as for everything else, you know, we could go through and we could rationalize this, and we probably should. You could say that till the end if you wanted to. I'm going to do it up here right now just so that we can see 32 over radical 3. And we're going to multiply the top and the bottom by the denominator to cancel out the radical 3. So just radical 3 right here, times radical 3 to the bottom. And then we also must do it to the top. We're multiplying by a big 1, right? It's just making it look easier. Radical 3 and radical 3. So on the bottom we have just 3, and this is 32, radical 3 up top. In any other situation, we'd want to say, hey, listen, the 32 and the 3, let's see if we can simplify the fraction, but you look here, 32 divided by 3 doesn't come out evenly, and there are no common factors that we can simplify it down with because, well, 3 is prime, and 32 is not a multiple of 3, so there's nothing we can do. This is how it should look. If you want to do all the work with the 32 over radical 3 and then save that till the end, you will get the same answer. I just think for me personally, it's better to do it right now. But if you want to do it a different way, you'll still get the same answer as long as you do your math correctly. So we got 32 radical 3 over 3. And then you're going to go through and you're going to find the area of that triangle. Area equals 1/2 base times height. I'm sure at this point you're getting tired of hearing me say area equals 1/2 base times height, because I've been saying it over and over and over, because that's what it is, right? It's just the same thing again and again and again, just repeating, repeating, and repeating. 32 radical 3 over 3, and then the height is 16, a much easier number to write than the 32 radical 3 over 3. And then we're just going to simplify. We're going to, depending on how you feel about multiplication of all this stuff, we could just multiply all this stuff on top, multiply all this stuff on bottom, and see what comes out in the end. Me personally, I'd rather just do the half and then apply it to one of these even numbers up here. You've got a 32, you've got a 16. It really doesn't matter which one you do. Half of 32, let's do that one. Half of 32 is 16. We got 16 radical 3 over 3 times 16. And remember, we're going to take this 16 and we're going to multiply it to the numerator. So 16 times 16 should be 256, I believe. Could just verify that real quick. Six times 6 is 36. 6 times 1 plus 3, that's 9. Then we're going to multiply by 10. And then we add those two and we get 256. Hey, hey, hey. We got 256 radical 3 over 3. All right, we're almost out of the woods. Just one more. And that's here. So if you remember going back to this one, our goal was to get the side, and we were halfway there already once we had the hypothesis. So actually, to be honest, this problem is easier than the previous one because there's less work to do. If we carve out our 30, 60, 90, and we just figure out what this is just times radical 3, so 8 radical 3. And then we need to figure out the whole side. Well, let's multiply that by 2, get the whole thing. That's 16 radical 3. And remember, to find the whole height, we divide by 2 and multiply by radical 3. So if you look, here's the base. Let's write that down before we forget. 16 radical 3. And then the height, we're going to multiply by radical 3 and divide by 2. So let's do this part real quick. The height is, well, half of 16 is 8. And then we're going to multiply, well, that radical 3 is already here, and then we're going to multiply that by another radical 3. Right? Because we're dividing 16 radical 3 by 2 and then multiplying 16 radical 3 by radical 3. So wait, radical 3 and radical 3, that's just 3, right? So we got 8 times 3, which is 24. And there's our height. 24. Looks a lot better now that all those radicals canceled out, doesn't it? So we've got the base is 16 radical 3, the height is 24. Well, now let's find the area of our whole thing here. Area equals 1/2 base times height. I'm sure a bunch of you are just saying that along with me. Now we're going to put in the base. The base is 16 radical 3. And the height is 24. And now we're just going to multiply. And then you get 1/2 of 16 is 8. And 8 times 24 is... do that out, 16. 192. Sounds right. And don't forget about that radical 3 on the end, 192. The radical 3 didn't have anyone to interact with because he's in quarantine. So you just put him on the end. All right. So if you have any other questions, please feel free to email me. Reminder, my email is right here if you need to get a hold of me. We'll come back on Monday for sure and get all of our other stuff done with what happens when you have less to work with, when you don't even have the benefit of being able to use a 30-60-90 or 45-45-90 triangle. We'll talk about what that is, and that does mean trigonometry. Hooray. All right. See you around.